In this lesson, I'm going to teach you about how the multiplicity of a zero affects the graph of its function. So let's look at the first sentence that I have here. It says the graph of a function is affected depending on whether the multiplicity of a zero is odd or even. So I have three different scenarios here that I want to describe to you. Let's start with the first one here. It says case 1, the multiplicity of a zero is positive 1. Now, if a multiplicity of a zero is 1, then the graph of the function crosses through the x-axis at that particular zero. So to look at this type of behavior, let's make a function y equals where its zeros have a multiplicity of 1. So you can always start with a factor x plus 1. Okay, so and since the zero is going to have a multiplicity of 1, the exponent on this factor is going to be positive 1. So we're actually going to graph a linear function here, y is equal to x plus 1, where the 0, or the x-intercept, is going to be at negative 1. So let's take a look at what happens on the graph here when I graph this function. So go to your y equals screen, plug in x plus 1, try a zoom 6 standard for now, see if that works, and it's perfect. And notice what happens at the x-axis at its 0. It crosses the 0 once at the x-axis. So if I was to draw my graph on my lesson here, here's my 0, negative 1, it's going to cross that 0 once, and that's what happens when your multiplicity of a 0 is exactly 1. Let's move on to the second case here, where the multiplicity of a 0 is odd, but it's greater than 1. So if this happens, the graph of the function is tangent to and crosses the x-axis at the 0. So once again, to describe this behavior, let's write out a function with this type of property here. So we could start with x plus 1 again as our factor. Since our 0 has to have a multiplicity of an odd number that is greater than 1, let's pick an odd number greater than 1, and that would be, let's pick 3. Okay, so we're going to graph this function here. Remember, the 0 doesn't change. X is equal to negative 1 is still the 0. So let's take a look at what happens at that point. So go into your calculator, clear whatever you had in there before, and you're going to plug in x plus 1 cubed. And let's see what happens at the x-intercept. We get a graph that looks like that. So yeah, once again, we still have a 0 of negative 1, but this time the behavior is different. It's tangent to, but it also crosses at that point. So if I was to draw this a little bigger on my lesson here, here's the 0. My graph is tangent to, so it just touches it, but then it also crosses it in the end, just like that. That's what it looks like when your 0 has a multiplicity of an odd number greater than 1. Okay, so moving on to my last case. The last case is where the the multiplicity of a 0 is an even number. And when this happens, the graph is tangent to the x-axis, but it also does not cross it. So tangent to does not cross it. Let's pick another polynomial here to graph. Y is equal to, let's pick the same factor, x plus 1. This time the multiplicity has to be an even number. So let's pick 2, which is an even number. We still have the same 0, x is equal to negative 1, but obviously the behavior of the graph at that point is going to be a little different than my last two examples. So go into your calculator, clear whatever you had in there. We still are using x plus 1 as our factor, but our exponent, our multiplicity in this case, is going to be a little different. It's going to be even, and we have chosen 2 as our multiplicity. So if we graph it, we have a quadratic graph, which is also known as a parabola. And that parabola, look what happens at its x-intercept, or its 0. At that point, it's tangent to the x-axis, but it does not cross it. So if I was to sketch this graph on the side here, here is my 0. The graph is a parabola that is tangent to the x-axis at that point, but it doesn't cross it. So please be aware of what the differences are between each of my multiplicities here, and that will actually help you sketch any type of graph there, knowing these three characteristics. So that is how you use the multiplicity to predict what happens at your x-intercepts.